We built machines to ease our muscles. Then, we taught them to speak, think, and dream. In less than a single human lifetime, artificial intelligence has evolved from science fiction into our daily reality. It paints our art, writes our code, and diagnoses our diseases. Yet, as it approaches human intelligence and perhaps surpasses it, we face an existential choice. Is artificial intelligence humanity's greatest invention or its greatest gamble?
QuestAns presents Artificial Intelligence. Where has AI reached? And from where?
AI, or artificial intelligence, is the science of building machines that can perform tasks requiring human intelligence. Instead of simply following fixed instructions, AI can learn patterns, make decisions, and improve with experience. Think of AI as teaching computers how to recognize, predict, and solve problems. But AI doesn't think exactly like humans. It processes enormous amounts of data at incredible speed. Some AI systems specialize in one task. Others combine many abilities together. This type is called narrow AI, the kind we use every day through our gadgets and computers. General AI, or general artificial intelligence, however, remains a future goal. An artificial general intelligence could potentially learn almost anything a human can. Whether such intelligence, termed as AGI, will ever exist remains one of science's biggest unanswered questions. Long before microchips, humanity dreamed of artificial life. In Greek mythology, Talos was a giant bronze automaton built to guard the island of Crete. In 16th century Jewish folklore, the Golem of Prague was shaped from clay, animated by mystical words. During the Renaissance, this fascination shifted from myth to mechanics, igniting an obsession with clockwork automata. Craftsmen built miniature mechanical dolls that could write, draw, and play music, almost replicating live humans. In 1673, G. W. Leibniz created the stepped reckoner, a mechanical calculator capable of all four arithmetic operations. Leibniz also formalized the binary system, realizing that all logic could be expressed using just zeros and ones. In 19th century, Charles Babbage envisioned difference in analytical engines, the world's first mechanical computers. Ada Lovelace wrote the first algorithm for Babbage's computing engine, becoming the world's first computer programmer. Literature soon caught up with science, giving this mechanical ambition a haunting moral frame. Mary Shelley's 1818 novel, Frankenstein, warned of the moral perils when humanity plays creator. Samuel Butler's 1872 essay, Erewhon, speculated that machines would ultimately go on to evolve to dominate humans. Then, in 1920, Czech playwright Karel Thenopek gave us the word robot in his play Rur, Rossum's Universal Robots, derived from the Slavic word robota, meaning forced labor. These robots in Rur eventually rebel and wipe out humanity. Sci-fi icon Isaac Asimov later introduced the 3 laws of robotics in 1942. Asimov's first law stated, "A robot may not injure a human being." Asimov's second law stated, "A robot must obey orders given by humans unless it conflicts with the first law." Asimov's third law stated, "A robot must protect its own existence, provided it does not violate the first 2 laws." Asimov's laws framed the debate. Can we code ethics into artificial minds? Fiction laid the groundwork. Science was ready to make it real. By the 1940s, the science had advanced enough to be close to realizing the dream of intelligent machines. Among the pioneers was a brilliant British mathematician named Alan Turing. During World War II, Turing helped crack Germany's Enigma code, shortening the war and saving countless lives. His work also laid the foundations of modern computer science and artificial intelligence. In 1950, Turing asked a revolutionary question: can machines think? He proposed what became known as the Turing test, a simple but influential way to evaluate machine intelligence. If one couldn't distinguish between a human conversation and a machine's, the machine could be considered intelligent. In the summer of 1956, a small group of scientists gathered at Dartmouth College in the US for a historic workshop. These pioneers, such as McCarthy, Minsky, Shannon, Rochester, and others, gave the new field a name: artificial intelligence. Back then, No one imagined their bold idea would one day transform the world and sow May fields in such a magical manner. After Dartmouth Conference, many optimistic researchers believed human-level AI could be achieved within a generation. But computers of that era were slow, expensive, and had very little memory. Early AI struggled with tasks that humans found surprisingly easy. Funding dried up, the hype evaporated, research slowed. AI entered its first AI winter, yet researchers quietly continued improving AI behind the scenes. In the 1980s, expert systems, programs built on particular subject expertise, became AI's first commercial successes. By the 1990s, faster computers gave AI a fresh chance to prove itself. In 1997, IBM's Deep Blue defeated world chess champion Garry Kasparov, showing AI's growing strategic mastery. This complex strategic victory of technology inspired a new wave of AI research. Instead of fixed rules alone, scientists began teaching computers to learn from flexible data. This new approach became known as machine learning. Scientists drew inspiration from the human brain to build artificial neural networks. Like brain cells, artificial neurons pass information through many connected layers. Each connection carries a weight that helps the network decide what matters most. By studying millions of examples, the network gradually improves its predictions. This process is called training, where mistakes help the AI become more accurate. These powerful networks became the foundation of today's AI revolution. In 2010s, AI entered a new era powered by deep learning. Deep learning uses many hidden layers to discover complex patterns in data. More data and faster computers made deep learning remarkably powerful. Researchers Geoffrey Hinton, Yann LeCun, and Yoshua Bengio advanced deep learning. Their work helped computers recognize images with astonishing accuracy. In 2012, a breakthrough in image recognition stunned the AI community. Deep learning soon transformed speech recognition and language translation. AI began understanding spoken words with near-human accuracy. Then came transformers, a breakthrough that reshaped language AI. Large language models, LLMs, learned from vast collections of books, articles, and websites. AI could now answer questions, write text, and even generate computer code. Generative AI soon created images, music, videos, and realistic human voices. Artificial intelligence had moved from laboratories into everyday life. Today, a paradigm shift has occurred. AI has transitioned from an academic discipline to the driver of world economy. Tech giants have poured hundreds of billions into custom AI silicon microchips and massive data centers. Today, AI transforms almost every major sector of human industry. AI assistants like ChatGPT can answer questions, summarize information, and help people solve everyday problems. In healthcare, AI can help doctors detect diseases and analyze medical images. AI can also search enormous molecular databases to accelerate the discovery of new medicines. Scientists working in various specialty fields use AI to find patterns in data that would take humans years to examine. In education, AI can adapt lessons and explanations to the needs of individual learners. In factories, AI-powered robots can inspect products, predict failures, and improve efficiency. Scientific research is accelerating. AI helps design new battery chemistries and novel materials. Farmers use AI, drones, and sensors to monitor crops, soil, and water. AI helps vehicles understand roads, recognize obstacles, and make rapid driving decisions. Banks and financial systems use AI to detect fraud and identify suspicious transactions. Smart grids optimize renewable energy distribution, slashing power waste in megacities. AI is no longer limited to calculations. It can now participate in creative work, like making art, music, or movies too. Even beyond Earth, AI helps spacecraft analyze data and operate with greater independence. Yet, alongside all these incredible breakthroughs lies an unprecedented wave of disruption. The very power that makes AI useful also makes it dangerous. First among immediate threats is the problem of AI bias and hallucination. Because AI models train on human data, They inherit our historical biases, prejudices, and flaws. When deployed in hiring, criminal justice, or loan approvals, biased algorithms exacerbate inequality. Then there is hallucination, where AI models confidently state completely fabricated information as fact. In a world flooded with AI deepfakes, reality itself is becoming difficult to verify. Hyper-realistic voice clones and synthetic media are weaponized for fraud, disinformation, and political manipulation. Labor market disruption poses another immediate economic shock. White-collar professions once thought safe copywriting, coding, legal analysis, graphic design face automation. While new jobs will emerge, the speed of transition may outpace society's ability to retrain workforce populations. Privacy is eroding as massive web scraping collects personal human data without explicit consent. Energy consumption is another rising crisis. Training single frontier models requires megawatts of electricity. Beyond present issues lies the long-term existential risk, the alignment problem. How do we ensure that an intelligence vastly superior to our own remains, aligned with human values and survival? If an artificial general intelligence pursues a goal misaligned with our safety, it could have disastrous consequences. Many AI pioneers like Yudkowsky and Hinton have warned that unaligned AGI poses an existential threat to humanity. Yet, the quest toward artificial general intelligence continues at breakneck speed. Artificial general intelligence would be capable of mastering any intellectual task a human can perform, and beyond. Some researchers predict AGI could arrive within decades, or even years. Quantum computing could accelerate this evolution by vastly outperforming classical supercomputers in complex tasks. Beyond AGI lies artificial superintelligence, ASI, a mind vastly smarter than all human brains combined. In medicine, ASI could cure cancer, eliminate genetic diseases, and reverse cellular aging. In physics and space exploration, ASI could unravel quantum gravity and design interstellar travel. Brain-computer interfaces like Neuralink aim to merge human consciousness directly with AI systems. This could unlock telepathic communication, instant knowledge download, and radical longevity. We stand on the brink of the greatest transformation in the history of life on Earth. Artificial intelligence is not merely another technology. It is a new form of mirror. It reflects our knowledge, our creativity, our history, and our darkest biases. The history of AI shows how far human ingenuity can reach when driven by curiosity. Its future will depend entirely on the wisdom, ethics, and safeguards we choose to establish today. The future of AI is not written in code yet. It is written by us.
Thanks for watching. Keep visiting for more QuestAns episodes.